here you can see in this case that it will not happen because due to the presence of source inductance, what will happen, it will try to resist conduction uh, at the time of triggering. It will resist the conduction, immediate conduction. It will take some time because you understand that inductance is the charge storing device. So what will happen, it will take some time to get its maximum value or maximum amplitude. So this way it will go. Okay, and it will after a certain time it will be the maximum point, and after and it will continue up to the next pulse given. So when next pulse is given, T1, T2 should be immediately off, but it will not immediately off because of the inductive effect. So again it will slowly decreasing. Similarly, when gate pulse, that is G3 by G4 is given, that is the when T3 T4 thyristor is on, then also it will take certain time to get its maximum value. So there also a transition. So what will happen during these portions, that is from alpha to certain time, suppose let us consider this time is suppose mu. Okay, at this time what is happening, you can understand that T1 and T2 is on here. Similarly, T3 and T4 is getting down, that is, it will be off there. So during this portion, you all understand that T1, T2, T3, T4 all are working condition or all are in conduction. So what will happen? All the thyristors is on means the thyristor is get getting shorted. So that time the output voltage should be like that. The output voltage at this point, that is from alpha to mu, uh, this portion all output will be zero because all the thyristors are getting shorted. So what the output we are getting, you can see that this should be the connection. That is, after mu, the conduction we are getting. After mu, we are getting the output voltage. Then again, it will go on conducting up to this pi plus alpha. And after alpha, from alpha, pi plus alpha to pi plus alpha plus mu, this portion, it will be again off. So this is our output voltage. Okay. This way it will go on continue the. Okay, so this is our uh, waveform. At this point, T1, T2 is on, and T1, T2 is on from uh, alpha plus mu. This portion, the T1, T2 is on up to this pi plus alpha, and T2, T3, T4 is on at this point. That is pi plus alpha plus mu, and from that it will uh, continue up to this portion. That is 2 pi plus alpha, I think. Okay, so this mu is actually known as overlapping area. Okay, during this time, all the devices are in conduction. So this is called overlapping area or overlapping angle, whatever it can be said. During this time, all the thyristors are on and the device gets short circuited. Output voltage is zero. Okay, so if it is being a ideal source, if I consider it is to be our ideal source, then the source current should be like that, square wave. And if I consider it to be the non-ideal one, then we will get a trapezoidal waveform like this. Okay. So conduction duration of thyristor, you understand, pi alpha to pi plus conduction duration of any thyristor is from alpha to pi plus alpha. Ah, okay. The overlapping area is mu. So overlapping period is 0 to mu, and alpha plus mu to pi plus alpha is the conduction. Therefore, conduction period is equal to pi minus mu. This is the overlapping area. So this portion is mu. So in between the portion, that is this one is the mu by 2. So fundamental component of the source current will pass through alpha plus mu by 2. The shape of the source current without source inductance is square wave, and now this is the trapezoidal wave. Now this is the output voltage. Output voltage or average voltage is equal to 1 by pi, the time period, and the conduction, as we have already shown, that the conduction started from pi plus mu and it is ended up to pi plus alpha. So alpha plus mu to pi plus alpha, Vm sin omega t d omega t, and with that integration we'll get this one. This is in equation 1. And during overlapping area, what is happening? The output voltage is 0. Okay, so the inductance we will consider is only the source inductance, that is Ls. So source current or source voltage will be the ultimately voltage because the output voltage is 0. So Ls, if I consider the source inductance, then Ls di naught dt will be equal to Vm sin omega t. And if I take the integration in this way, that is Vm by Ls, that is di naught equal to Vm sin omega t dt, Vm by Ls. Let us consider this as constant value. Then we will get what is the current limit. Here we can see in this picture minus I naught. This is minus I naught to plus I naught. And since it is dt and we have to change the limit with respect to dt, that is uh, in place of d omega t we are writing dt. So uh, we have to replace this omega t as this one, alpha by omega 2 alpha plus mu by omega. And here we'll get 2 I naught is this and I naught value is like this. Now from the equation 1, in this equation, if I put cos alpha plus mu, this value, if I put, then we will get V naught value. There you have to solve it and you will get the output voltage like this. So this is the value, you can say V naught equal to 2Vm by pi cos alpha. 4 FLS I naught. This 4 value is actually the number of S years. Okay. And here LS is the source inductance. If LS is 0, that is ideal case, then the value will be like that. If L is equal to 0, then it will be single phase full wave rectifier into voltage average. And this is the three phase half wave rectifier. This is three phase full wave rectifier. These are all the same things. Okay. So from this equation, that is 2I naught, 2I naught equal to Vm by omega Ls into cos alpha minus cos alpha plus mu, we can get 2I naught omega Ls by Vm equal to this. If I multiply both sides by Vm by pi, we'll get this value. Okay. So the regulation is equal to drop due to load at a given power factor. So that is equal to drop due to Ls divided by average voltage without Ls. So drop due to Ls is Vm by pi, this value, by 2Vm cos alpha by pi. That is without source inductance. Ls is source inductance. Without source inductance, drop due to without source in due to inductance, source inductance, and average voltage without source inductance. So that is the percentage of regulation. Okay. And if it is zero, then it means no drop. So this is all about the effect of source inductance in case of full wave converter. Up to this, anybody has any question?